Alright guys, let's continue with solving equations, this time with fractions. A little bit more trickier than the previous section, but let's keep it to the rules and then it's going to become very easy. So let's look at the first example. First example, let's call it number 1. And I'm going to start writing 1 down by saying 3 x plus 7, and then everything in a fraction, let's say over 2, equals to be 5. Now guys, before I'm going to continue with that, I just want to make sure that we can remember what is a term. A term is something like this. If I'm going to have x plus 2 equal to 5, then I must know a term gets separated by either a plus or a minus. So then I'm going to have one term there, and then obvious a term himself on the right hand side. But when I'm going to do it like this, x plus 2, and I connect it with a division sign, let's say over 2, immediately, because of the division sign, it connected to, and the whole thing become now a one term. And then obvious, the one term still on the right hand side. So that was one very important fact. If I'm going to take that same value again, x plus 2 equal to 5. Once again, from that one, I know that there's a term, there's a term, there's a term. But when I'm going to write it now as x plus 2 equals to 5, when I put a bracket around it, the bracket means, and I'm showing the bracket, it means that that whole part now becomes one term left, one term right. So yes, this understanding of what is a term, when is a term, for me is very important in understanding that. So let's start with this one. So I can see on the left, in this case, I have one term. So my first thing is I want to get out of the fraction. I do not like playing with fractions. So I'm going to say on the left, multiply with a 2 over a 1, so that the 2 and the 2 can cancel. What I then do on the left, I must then also do on the right. So I'm going to be left now with 3x plus the 7 equals to be, and now 2 times 5 is going to give me a value of 10. Now I'm going to start, take the 7 to the right hand side. It's going to become now 10. And now the 7 will become minus 7, 3x on the left. Then still on the left, 3x equals to, and now 10 minus 7 going to give me a value of 3. Now what must I do to get rid of the 3 on the term left? I'm going to divide now by 3 so that they can cancel. What I do left, again, I must do right. So therefore I'm going to be left now with x equals to be, and 3 divided by 3 going to give me a value of 1. Now to test this answer is going to become a little bit more tricky. Let's see. If I go over to the test, I'm writing it down, namely 3x plus the 7. And keep in mind, everything over 2 equal to be 5. I'm substituting the 1 now. So I'm going to have 3 multiply. I'm going to put a bracket for x, and x value, according to my answer, is 1 plus the 7. Divide that by 2 equals to be 5. Then I know that 3 times 1 is 3. Plus the 7 going to give me a value of 10. Divide that by 2 equals to be 5. Then I see that 10 divided by 2 going to give me a value of 5 equal to be 5. And once again I see my left hand side indeed equal to be my right hand side, and through that I know my answer must be correct in that particular case then. Now for example 2. If the question is something like minus 2x divide by 3 plus the 9 equal 2, then the first thing I must realize, I'm having two terms. One term there, one term there. My first objective is to make sure that the term with the x, the variable, stands alone on the one side. So therefore I would like to take the 9 therefore to the right hand side. So I'm going to be left then with minus 2x divided by 3 equals to be, and now 2, as the 9 cross, it's going to become minus 9. So I'm going to have now minus 2x divided by 3. And now on the right hand side, 2 minus 9 going to give me minus 7. Now on the left hand side, I would like to get rid of the minus, the 2 and the 3. So I'm going to multiply now with a minus. Why with a minus? Because a minus times a minus is going to give me a plus. And then if I want to get rid of the 3, I'm going to multiply with a 3 over a 2. So that that 3 and that 3 can cancel, that 2 and that 2 can cancel. And then I know the rule. What I do on the left, I must do on the right. Multiply a minus 3 over 2. Let's see what I'm going to be left with now. On the left hand side, all that have cancelled, I'm only left with the x equals 2. Now, a minus times a minus is a plus, which I do not really have to show. 7 times 3 is going to give me 21 over 2. And it's fine. We can leave the answer in the improper fraction. But now the testing part is going to be a little bit more difficult because we are playing with the improper fraction. But let's see. I'm going to have minus 2x divide 3 plus the 9 equals to be 2. First of all, I'm going to substitute my x answer, namely minus 2, and now the x going to become 21 over 2 and everything over 3 plus 9 equals to be 2. I can see now, if I grab my pencil quickly, that 2 and that 2 going to cancel because strictly speaking underneath that 2 stands a 1. What am I left with now? I'm going to be left now with minus and then 21 divided by 3 plus the 9 equals to be 2. Then minus, and I do know underneath actually stands a plus. So a minus divided plus is a minus. 21 divided by 3 is 7 plus the 9 equal to be 2. Then minus 7 plus 9 is then plus 2 equals to be 2. Again, my left hand side equal to be my right hand side. So my answer through that have to be correct. Example number 3. I'm going to give you 3, but this time we're going to play with brackets. X plus 2 equal to be 10. Now there are many ways in doing it. I would like to do it like this. I like the idea to get rid of the brackets first. So I multiply it into the first term into the bracket. So 3 times x going to give me 3x. And again, bring the sign down. Now, 3 times 2 going to give me 6 equals to be 10. Then I'm going to take the 6 to the right hand side. So I'm going to have on the right 10. The 6 crossing become minus 6 and then 3x on the left hand side. Then on the left hand side still 3x equals to be 10 minus 6 going to give me a value of 4. Then I'm going to say on the left divide by a 3 so that the 3 and the 3 can cancel. But I know what I do on the left, I must also do on the right. Therefore, I'm going to have for answer so far x to become equals to 4 divided by 3. Once again, I have an improper fraction. So now I have to go and test my answer. I'm writing it down. 3x plus the 2 equals to be 10. In the place of x, I'm going to put now 4 divided by 3 plus, and I do know underneath the 2 actually stands a 1 equal to be 10. Then I'm going to have 3, and now one of the rules, there are many ways in doing it, I'm going to say I'm looking for a number where the 3 and the 1 can divide into. So the number must be 3. 3 divide into 3, 1. 1 times 4 is going to give me a value of 4 plus the next one. 1 divide into 3, 3 times. 3 times 2 is going to give me 6, and I close the bracket equals to be 10. Now I'm going to have, and I see now if I look at this one, 3 inside the bracket I'm going to have now 10, divide that by 3 equals to be 10. Strictly speaking, I know that underneath that 3 stands a 1. So I can say that the 3 and the 3 are going to cancel on the left hand side. So therefore my answer on the left is 10 equals to be 10. Again, my left hand side indeed equal to be my right hand side, and therefore I know my answer must be correct. The next examples I would like to share with you is exponents, exponential equations. We have done already some of it, but let's just go over it again. If I'm going to give you a value of 2 to the exponent x equals to 8, then I do know that 8, and I must know that 8 is equivalent to a value of 2 times 2 times 2. It means that the 8 I've used the 2 3 times, so it's 2 to the 3. So I'm going to substitute it by saying it's 2x equals to 2 to the 3. Then again I know that I'm having one term on the left hand side, one term on the right hand side, and because my terms base values are the same, I'm going to cancel the bases, so my answer going to become x equals to be 3. Let's test it quickly. So therefore I'm going to have 2x equal to be 8. Now I'm going to substitute it. It's going to become 2 to the 3 equals to be 8. And I know that 2 cubed is going to give me 8 equals to be 8. My left hand side equal to be my right hand side. And I know then my answer must be correct. Example number 5. Still exponential equations. If we're going to have 5 to the exponent x, 5x plus 2 on the exponent side equals to be 25. Before I'm going to continue with that, and we have done this before, one of the exponent rules, a to the n multiply a to the m equals to a n plus n. And you know it as if the bases are the same. Multiply. I must add the exponents. Don't forget that sing-song, it really helped me remembering my formulas. So here we go. And I'm going to say, if the bases are the same, because I realize that a bracket means a multiplication. So if the bases are the same, what must I then do with the exponents? I need to add them. So I'm going to have x plus. What must I plus? I must plus x plus 2. X plus 2 equal to be 25. Now, on the left, I'm going to have 5. Do I have likewise terms? Yes. The x and the x are going to give me 2x plus the 2 equals to, in the same process, I do see that my base on the left hand side is 5. And I do know that 25 is something like 5 times 5, meaning it's going to become 5 square, 25, which I'm going to substitute it then with by saying it is 5 square. Now, on the left, I'm going to have one term on the left, one term on the right, which the basis of is the same. So I'm going to cancel the basis. So I'm going to be left then with 2x plus the 2 equals to be 2. Then I'm going to take the 2 to the right hand side. So I'm going to have 2x equals to 2 minus the 2. On the left, 2x equals, and I can see that 2 minus 2, of course, is going to give me a value of 0. Then what I do on the left, I do on the right. I divide by 2 so that they can cancel. Therefore, on the right, divide by 2. That means I'm going to be left now with x. And I must know that 0 divide anything is going to give me a value something like 0 in this particular case. So that's going to become my answer. So don't forget the formula where we're going to say that 0 divide any number except 0, of course, is equal to 0. Now I have to test my answer to see if I can find the correct part. So let's see if I go over to the test. I'm going to have 5. In the place, let's first write it, x bracket 5x plus 2 equals to be 25. In the place of x, I'm going to have 5. In the place of x is 0. 5, 0 plus the 2 equal to be 25. I do know that 5 to the 0, anything to the 0 equals to be 1. So I'm going to have 1. Let's just write it down. A to the 0 is equal to 1. But don't forget, A is not allowed to become 0. So there's another statement that we must remember. It seems to me the formulas are really adding up in this calculation. So we're going to continue now here where we're going to say 5. 0 plus 2, obvious, stays 2, equals to be 25. Then 1 times anything is still, so I'm going to have 5 squared is 25 equals to be 25. It seems to me again that my left hand side indeed is equal to be my right hand side. And through that again, I know my answer must be correct. Right guys, now it's your chance, your turn, helping me with some answers in the section. Question number 1. Let's call it homework. Number 1. I'm going to ask you 9 minus 3x minus 15 equal to 9x minus 6 minus 15x. Number 2. 5 minus 2 x plus 5 equal 3 minus 3 x minus 1. Question number 3. 3 bracket x plus 2. Everything divided by 5 equal to 3. Number 4. 3x plus 5 divided by 4 equal to 2x plus 4. Number 5. 2x plus 3 plus 5 and everything there over 3 equal to 5x plus 2. Number 6. 3 to the exponent 2x equal to be 81. Number 7. 5 to the exponent 2x plus 1 equal to be 125. Number 8. 3 multiply 5 to x plus 4 equal to 75. Number 9. 2 x plus 5 divide 4 equal to be 2. Right guys, I think that will do the trick. I really hope in my heart you're going to challenge these couple of calculations. Don't give up. Keep on going. Look at the rules nicely. And we will talk later again when I'm going to do the answers for you. Thank you very much, guys, and have fun.